Hello viewers, welcome back. Today we'll discuss about SR and RS flip-flop. It is mainly used to store the data or information. It stores the data as 1 or 0. To use the SR flip-flop, we have to go to instruction library from right side here. Then click on the bit logic operation. It will available here as SR and RS flip-flop. Now drag and drop the SR flip-flop on the network. Now from this block we see that it is mandatory give a tag here. This tag a in out bool type, binary type tag in out. We can use this tag as a local tag from the data block, or we can use a flag memory. For now we'll use flag memory. I already rename it as a SR memory M10.0. We don't need to give, it is not mandatory to use a output here. So let's see how the SR flip-flop hold the memory, store the memory. Suppose we have a motor with a motor protection circuit breaker. So we want to take the status of this circuit breaker. It is trip or okay, it is trip or it is on. So there is a auxiliary contact. When breaker is turned on, that time that auxiliary contact NO will NC, and if we use a 24 volt supply through this contact, we will get 24 volt to our module. So 24 volt supply in module means it is logical 1, and 0 volt means logical 0. If we connect that input 24 volt to signal IO module address I0.0 to set that SR in SR flip-flop. So when it is set and again turn the breaker on, that time we need to reset it. So we give a 10.2 address as a reset. Let's download. See, currently I0.0 is missed. That means power from here to input S is true. Okay, and breaker is trip. That time memory is set, SR is set. If we use this SR memory as a input of any logic or make a fault, we can use like this, that SR here, and we want to generate a fault like 10.1. again download. Okay, see, it is set and it trigger fault bit M10.1 as a 1. Now we want to turn on the breaker by forcing this IO. Double click, it will open. I am going to plot this window. Okay, now I am forcing this IO I0.4. I am forcing this IO I0.0 to 1. That means breaker is turned on and 24 volt goes to memory. That time this NC will be NO and S is low. Now I am resetting it by make it true. Again releasing that reset button. Now it is 0. Now if the condition S1 is high and R1 is high, that time what will happen? Let's see. I am turning off that breaker. It will make a fault. It will make a fault. Now I am resetting it. It is reset. So it's not a good logic that your fault is there and when you press it is reset. So from SR we see that when S and R is true, that time its memory is resetted, means it's a reset dominating SR. So we want to use RS flip-flop. So this is a I 0.0. By this input we want to set this RS flip-flop. So we have drag and drop to S1 and we should give reset button to R input. So here M10.2. Now I am going to download again. See, before it was reset dominating, means S1 R S and R both are high. That time the memory M10.0 was resetted, means it restored 0. Now both one is true, means both one is high. That time M10.0 is true. So RS flip-flop is set dominating and SR flip-flop is reset dominating. So to create a fault we should use RS flip-flop. Okay, thank you.